this topic, we'll discuss the R implementation of plots and charts. The basic building blocks of these plots and charts we have already discussed in the fundamentals of R module. Now we'll apply those building blocks and create charts and plots that are very aesthetic in nature. As a starting point, we'll set the working directory first. We'll go to the session, set working directory, choose working directory. We'll set the working directory where we want to save the plots and read the data. So we'll copy this setwd command as we have been doing at the beginning itself. So in the future, whenever we want to use it, we can simply run this command and we need not remember the location. So we'll start with the data visualization. Now, as a first example, we'll take gasoline price data. We'll import data set from this import data set option from Excel, and we find that there is a gasoline price which we'll select. We'll import the data. A certain set of commands are run. So we'll copy these commands, and again for future reference, we'll copy paste these commands from console to our R script. So whenever we need them in our future application, we already have them ready. So we have the data which is read. If you want to see the data, a very easy way to do that is just type head weekly gasoline prices. So we can see the head of the data. It contains weekly dates and gasoline prices in dollar per gallon. Let's start by plotting this data. We already have some understanding of plotting. So we'll write the command as follows: plot command weekly gasoline prices, which is the series to be plotted. Then we want the plot to be of type L, line plot we want. Then we want the central heading to be time series. This is the central heading. We can change the name as per the requirement. Then column we want as red, and type LWD, line width as 2. So we have seen this argument. We'll set the line width to 2. Then we can run this command, and notice a very nice looking plot has been produced. You can zoom it. The screen can be zoomed. You can see the plot. There are number of permutation combinations. For example, you can export this plot, save as PDF, save as image, or you can copy it to clipboard, adjust the dimensions of the plot as you may wish, and then copy it and then paste it in your Word document or PPT or anywhere you would like. As a next step and a more efficient way to do plotting in R is to use the library zoo. For time series, like we have just saw, zoo package provides nice plotting functionalities. So we'll make use of library zoo, and we'll convert this original series into a zoo series. It's very easy in R. We'll use the zoo function. Now that we have to specify the series we want to convert. So the series to be converted is prices, and you also need to give the time element. So the time element is date. So we'll also use that. So notice I'm giving the price series along with the date dimension. And if I run this command, it will be converted into zoo series. If you do not have zoo installed, you need to go to tools, install packages, and then type zoo to install this functionality. If you already have zoo installed like I did, then you simply need to run the library zoo command to add the zoo functionality in your current working environment. Now once you have added that, a very easy way to plot this, or first we'll convert this zoo series into quarterly. Currently it is on weekly basis and slightly noisy. There are a lot of fluctuations as you can see on the plot. So what we'll do is we'll convert it into quarterly series, and with zoo functionality that is very easily available, we can use as.year quarter. So it will be easily converted into quarterly series. Now if I run this WGP1, which is the new series, that is now quarterly series. So if you want to see the plot, it's very easy. I can simply use the previous plot command itself, and I'll just plot both of these commands. So in the quarterly series, I need to simply type WGP1, and I'll use the green color probably. What I'll do is I'll try to superimpose, put these graphs together. So for example, this mfro command, I'll use mfro. This mfro helps plotting multiple plots in same window. Basically, I need par mfro equal to C 2 comma 1. So with this I can plot two plots in same window. Now along first I'll plot the original plot, which is weekly series. First I need to run this KANPUR-NPTEL command, then plot original plot, and then next plot. Or even better, I'll do something else. I'll time series weekly, time series quarterly, and let's plot them now. Notice the plots. I'll just zoom the plots, and you notice that the one which is quarterly is much more smooth, gives clear trends, while the one which is in red, which is weekly, is much more fluctuating, which is on the expected lines. So with this we have understood the simple plots. We can also practice with a little bit with bar plots, and in next set of videos we'll see bar plot application in more detail. But as a simple example of bar plot, I can simply type bar plot. I need to specify the series, so I'll use the quarterly series because it is less noisy. I will type y-axis as quarterly prices. It's very easy, quarterly prices. I also need to give the x-axis, so my x lab is equal to date, and I need to give the color. Color is blue. I want the graph to be blue. I need to give the central axis. You will notice that same features are used whether plot or bar plot. This is the power of R. These are just building blocks that you once you learn, you can apply them in different set of plots like bar plot, simple plot, histogram, and so on. I will be giving the border as red. Now we are good to go. I'll just plot it and zoom it for you. Okay, I need to do the KANPUR-NPTEL as 1 comma 1, otherwise it will be plotting expecting two plots. So we'll do KANPUR-NPTEL 1 comma 1, which will tell R that now only one plot on one window. Now I'll run the command, and once I run the command, notice the plot, very nicely shaped bar plot for quarterly prices is plotted, and the boundaries are red, actual bars are in blue, and it gives a lot of good information about the price movement. So this is the simple bar plot. In the next set of videos, we'll learn some more plotting with different data sets. In this demo, we'll visualize the economic outlooks of different countries around the world. In this video, we'll make use of another dataset, which is nations dataset. We'll go to the import dataset as we did earlier, and then import nations data. Click on import. The data will be imported. A brief visual examination of data can be done on the screen. We'll import this. It is also viewed on the RStudio, which seems to be correct here. So we'll keep this data. We'll copy paste these commands for future use that have been used to import the dataset. They'll be very useful. Now, if you want to check the data, you can simply use the head command, head nations. Let's see what is this. So the data carries member nations, their status with UN, their different PGP, per capita GDP, trade deficit rating, and their outlooks for different member nations. So let's start with first telling R that this outlook variable is a factor variable. So this is basically rating outlook. Ratings we can see here in the rating column. Outlook is stable, positive, or negative depending upon the outlook of rating agency. They assign these values, stable, positive, negative. So we'll tell R that this variable is actually a factor variable. We have discussed a lot what is factor variable. So we'll tell R that this is a factor variable. We can use as dot factor or simply factor command to tell R that this is a factor variable. Now that we have explicitly stated it as a factor, let's check the levels and of this factor variable. So we find that there are three levels: negative, positive, and stable. As a starting exercise, we'll make a very simple bar plot, and we need table nations dollar outlook, and we'll first plot the main bar plot. So if we plot it, we can see a very nice looking bar plot with gray color. All the three levels, negative, positive, and stable, their frequency is plotted. You can also visualize, you can directly not only visualize, you can see the frequencies with this table function. You can see that. So negative 11, positive 10, and stable 39, as you can see in the console window. You can rotate this plot. Instead of this, you can use horizontal as true. So if I do that horizontal as true, the graph will be tilted a little. So that those permutation combinations you can do. Let's do a little bit more aesthetically improved graph now. So for example, I can use this same command and I can add some more features, starting with Let's say I can change the color. Let's change color equal to rainbow. Maybe since there are three, we'll use rainbow 3. Then probably we'll use, I can use, you can give any name to y-axis. So probably I can give y-axis. You can change it to anything that you may find more suitable. Similarly, I can give x left as x-axis. That can also be changed as may deemed suitable. You can set border also. Let me set border as maybe green. We'll see how it appears. We can change it later as well. So let's just run it. So notice a very nice and interesting looking graph is appearing. Y-axis, x-axis labels and everything. So I can change it. For example, I can change y-axis to frequency, which sounds more suitable here, and x-axis to the outlook. Central heading I can change to rating outlook. Let's see how it appears. So if I run this, a very nice looking and very aesthetic plot has appeared. Now on this chart, you can add legends also. For example, if you want to add legends, you can simply use this legend command, and you can put this, maybe top left seem to be slightly empty, so I can put the legend on top left. Then I can specify what are these legends. So I have negative legend, negative, one value is negative, one is positive, and the next is stable. Now the fill also will follow the same fill, rainbow, which is rainbow 3. So to make it more consistent, and we'll plot it, and then we'll see the how it appears. So if I run this, it seems nice. We can zoom it. You can see it is quite nice. Although if you wanted to change the shape and size of this legend, you can use the cx command, cx, as maybe if you want to decrease it, you can use it 0.4, although it may not look very nice, but let's see. So it's quite small actually. If you want to make it large, maybe you can make it too large with 6 equal to 2, and it seems to be too large actually. Although when I zoom it, it seems okay, it's too large. So we'll make 6 equal to 1. Probably that would be more appropriate here. And yes, it seems to be. So here a very nice and aesthetic looking chart is appearing, which we can copy paste and use in different purposes. In this video, we'll visualize frequency distribution and relative frequency distribution using soft drink data. Again, we can go to import dataset, Excel file. Since it is an Excel file, we'll go to soft drink data file, cold drink data. Again, the data will be visible on our Excel import, and we can see it's a sort of name of cold drinks like Coca-Cola, Diet Coke, Pepsi, and so on. We'll import it. A view will be appearing on our studio window. We can see what is the data, how does it look. Now that we have imported the data, we can again copy paste these commands that are appearing in our console. It can be useful in future. Now first probably we'll do the head cold drink data. I'll change the name to soft drink to make it more easy to use, soft drink. Now let's see the summary of data, summary of soft drink data. I can put the head to see what is inside this data. So you have Coca-Cola, Diet Coke, Pepsi, and so on. Now as a starting point, what we'll do is we'll convert it into a tabular form. So for that I need to just modify a little bit. I'll use cbind.data and we'll see the impact cbind. So we are converting it into a data frame, and inside data frame, first let me show you what is happening. So I'm using the table function soft drink. So it will create a sort of table with frequency of different brands, so Coca-Cola, Diet Coke, and so on. And when I put this table function inside cbind data frame, a data frame will be created. In this data frame you have soft drink with two columns, soft drink and frequency. Now this kind of data is very suitable for plotting on bar plot. So let's try to first compute the relative frequency of this data. So soft drink dollar, and we'll create a new variable as we have already seen, which is called relative frequency. In the relative frequency we have soft drink dollar frequency divided by sum of soft drink. dollar frequency, which will give basically the relative frequency, a sort of probability of some sort. So we compute that. Now we'll plot this bar plot. We'll make use of bar plot command, soft drink dollar relative frequency. Now we need to give the names. So names.arg, and it's quite easy. We can simply use the name column, which is soft string dollar soft drink, which is the name, and we need to specify the color. One way to do is to explicitly specify the color. We'll make use of numbers. R recognizes numbers as colors as well, so we'll make use of 5 colors because there are 5 cold drinks. So if I run this, a very nice looking plot has appeared. We can zoom it. So this is the plot. Now if you want to play around with the colors, a very interesting way is to use rainbow colors. So in color I'll use rainbow 5, then it will provide me rainbow 5. Very nice looking colors will be appearing, as we can see here. You can also shift the graph by making this horizontal argument as true, then the graph will become horizontal. I'll make a separate command for reference, so you can make horizontal equal to true and the graph will be tilted. Now another way to improve this graph would be to add the legend. So first I'll go to the previous plot. Before adding the legend, I would like to print it in the vertical form. Now a good legend will make or improve the aesthetic aspect of this plot, so I'll add the legend. That is quite easy. So legend, it seems probably, let me fix the at top right. You can place the legend wherever you find more convenient. Let's put it at top right. Legend, top right seemed to be slightly empty. Now in the legend I would be adding short forms of these cold drink to make it more suitable. CK for Coke, DCK for Diet Coke, PEP for Dr. Pepper, PSI for Pepsi, and SPR for Sprite. So this will be my legend, and then I need to just add some fill colors. So probably I'll add a fill of rainbow 5, which I have already used. So I'll use rainbow 5 for fill so that color coding remains consistent, and I can see it is slightly, it's nicely looking but slightly overlapping. So I can change the 6. Probably I can decrease the 6 to 0.5. maybe it will be a slightly smaller plot and smaller legend, and yes it is, but doesn't look so good. So maybe earlier one was better, so I'll use it as 1, which is the original thing, and it looks nice. All the bars are recognized. Also we can add pie plots to represent the same data. We'll start with the pie plot. Let's see how it works. A very simple pie plot is available in basic R functionality. You can use pie, then relative, since we are plotting the relative frequency thing, we'll use the data, which is relative frequency data. Again we need to add the labels as we did earlier. Labels will remain same, so the labels will remain same. I'll use the same labels. I need to give a central heading. Let's give it as main equal to soft drink. You can change it as may be convenient, and then you need to specify the colors. Probably I'll use colors as rainbow 5. You can choose any color, give explicit names, red, blue, green, or use numeric coding 1 2 3 4 5. I'm using rainbow 5. So now I'll just plot this, and a very nice pie chart has appeared. We can see that this pie chart, you can export it to PDF or do as you may wish. Another way to represent this thing would be in a different manner, would be to use the same pie plot, but in the labels, rather than using the name of the cold drink, I'll use their distribution, the percentage share. So for that I'll do a little bit of trick. What I'm doing, I'll show you. So I need to create the percentage share, which I can do it like this. I'll use base 0 for adding few characters. I'll use the round command so that the percentage is in 2 digits. So I'll use the round thing. I'll multiply 100 with the relative frequency. Relative frequency is the sort of probability that we computed earlier, and I'll specify that we want only 2 up to 2 decimals. Then we'll add a percentage here because we want to show that it's percentage number since we are multiplying with 100. And let's see what we have produced here. So if I run this command, you notice the percentage shares are appearing now. So I'll copy this, and in the labels I'll use this. I'll use this as a label, You can see here what command I have put. I have used the label as those percentages, and I'll run this. Notice now labels are appearing, but again the problem here is that we have lost the original names of the cold drink. So we need to add a separate legend to show the label. So I'll add separate legend here. In the legend, probably top right would be appropriate. So I'll use top right. You can use top right, top left, or any place that you may find convenient. Again, I need to specify the label. So I'll copy the original label from here that I have already put. I need not type it again. So I'll use the original label. Now I can specify the sex as 1. If not appropriate, we'll change it. Again, the color coding will make it consistent as rainbow 5. And let's see what happens. So if I add the legend, they are slightly appearing on the side of it. Probably, sorry, I need to add fill equal to. I'll slightly modify it a little, and yes, so now it looks very nice. The legends are added and everything is fine. Legend size also is same, fine. If you want to decrease the size of the legend a little bit, you can use 0.8 here. Probably that would be more appropriate. Let me try it. And yes, it is slightly appropriate. So this is how we plot the pie chart. There's one more addition that you can do with the help of Plottrix library. If you have not installed, you can, since I have already installed, I can simply go to my library function and add this Plottrix. If you have not, you can go to install packages, select Plottrix, and then install it. Since I have already done it, I will directly add library Plottrix and add the Plottrix functionality to my current working environment. The advantage and benefit of Plottrix is that I can add 3D pie charts. Syntax is quite similar. I simply copy paste the original thing which I did earlier. So I'll simply copy paste. I'll simply copy paste the original argument that I used in the pie function. It will remain identical, and I'll run it. And you notice a very nice 3D pie chart has been produced. I only need to add legend. I'll use the same command for legend, no changes. I'll use the same command for legend and copy paste it here. A very nice legend will be produced. So it looks slightly less sharp. So probably I'll decrease the, okay, so too small. So you can play around with the size to see whether it is visible or not. Probably top left. Let's try top left. Let's see what appears. Okay, so here it appears to be fine. So I'll increase the size to 1. Okay, so now it is appearing. So we can see the legend also now on our 3D plot. So this is how you can produce 3D plots also. Now that we have understood bar plot and pie chart, we'll try to understand plotting histogram in R. As a starting point, we'll create a random variable sampling observations from 50 to 100 with the 10,000 size and with replacement. So this is our variable which ranges from 50 to 100 with 10,000 observations. Let's see the summary of this variable that we have created. So it ranges from 50 to 100 as we thought of. Now, as a very basic histogram plotting to start with, we write this hist command var. We can give xlab as frequency. We are very familiar with these notations. Ylab as variable maybe, or you can give it any name as you may find suitable. It would be nice to give color as maybe rainbow 20. Depending upon number of bars, more or less colors may be used. Border I can use green. So for example, here we have, if we have 10,000 observations and you have given breaks, and now this is a very important argument, break. This tells our how many breaks are to be created. So if there are 10,000 observations and you give 100 breaks, then each bucket or each frequency bucket will carry 100 observations. So let us give 100 breaks equal to 100, and that will also determine how many colors will be used. And we can see here a very nice histogram. You can zoom it, see different color codings. Now this break argument is very critical. Let me show you its application. So what I'll do is I'll create space for 3 plots, 1, 3, and I will change the breaks. So what I'll do is I'll create histogram with different breaks. So 100 breaks, and the next one I'll use with 10 breaks, and the other one I'll use with single break, and we'll notice how it works. So I'll just enlarge the plotting window a little bit and let me use it. So paramfro equal to C, I missed one argument. Now first plot 100, 10 and 1, and notice how the distribution changes as I change the breaks. So it becomes more and more homogeneous, because at an extreme case is one break, so all the observations become part of one bucket, so only one bar, while another extreme case is 100 breaks, so each bucket carries 100 observations, and the middle case is 10 breaks. Now we'll look at some of the plotting arguments. We'll again use par_info 1, 1, and we'll add some features in this plotting. So we'll use par_info 1, 1 to plot single plot with 100 breaks, but now we'll try to make use of some of the more arguments, starting with central heading. So for example, you can add a central heading to this main. Earlier there was no central heading, probably we'll use a central heading called histogram. That is one heading. You can also increase or decrease the size of the central heading with the argument sex.main, maybe 2. So enlarge this. You can also change the font. If you want to change the font, you can use different fonts. Let's use 4. You can also change the axis sizes. So let's say axis 3, which will increase the size of axis. You can change the label colors to green. Axis labels maybe green. Central heading also you can change. So probably if I want to use central heading to red, I can use that red. Then you can use the axis, the numeric values that are plotted on axis. You want them to be a certain color, maybe black, I can use that. And the size of axis maybe 1. So with these arguments, I can run this. Okay, I need to use par_info 1, 1, and now it is produced. So you can see the central heading is red, axis labels are green, axis numeric values are black as we have plotted. You can change all these things. For example, it seems that sex label is quite small, so I can increase the size of. Notice the labels at the axis have increased. Sex axis is quite large, so I want to decrease that. I'll put at 1. So now the numeric values will be decreased. So you can play around with these permutation combinations. Now, many times you need to plot rather multiple plots in one window, or also sometimes you need to add numeric labels on these plots. So for example, I'll make use of the original this plot command, hist command. If you remember, when we plotted this, we had 10 breaks, so we can see those. That is the plot we got. Okay, so this is the plot that we got. I'll again put it. So this is the plot. Now I want to save this plot object. If I run this command, the plot object is saved in a variable m. Now I want to make use of this variable m in order to give labels. So I want to use the midpoints of these buckets. So each bucket will have a midpoint which we want to use. That will be our x coordinate. Y coordinate is counts. This is our y count. And the labels we want to set the labels as counts only. So the counts will be our labels. We wanted numeric counts, and we would position them with this argument. You can adjust the position. It's just that this position I found more suitable and optimum for this kind of plotting. Notice this. So you have numeric labels associated with each bar, which look nice. It gives you some exact idea of the size of the bars. $mid is the x coordinate, $count is the y coordinate on xy axis, because x axis is frequency and y axis is variable value. So we have set the coordinates and then labels as counts, and we could add the labels. Another interesting thing that you can do is plotting two different data or two different series on this histogram. Let's see how to do this. So again, we'll start by setting the margin. That is very important here, because we are plotting two plots. We need to give sufficient margin. So we'll use this par margin equal to C. I will slightly adjust the margin. You can play around with these numbers to see how it fits in your case. So I'm setting the margins of the plot. Once I set the margin, I'll plot a very basic R plot. Let me plot that. So I'll plot the histogram, and let me plot the histogram. I'll make use of the original command. So this is the histogram. I'll probably set the main heading also here. So main heading as histogram. and let us plot this. So like I said, you can play around with this. Maybe I should use single color, maybe here color equal to black or rainbow. So this is my, this seems to be appropriate. I'll not change it. Now you can play around. For example, you can increase the margin to, let's say, 0.5. Notice how it changes the entire thing. Or if you want to further increase the margin, I will increase on all sides. If you want to increase or decrease margin on a particular side, you can do it right here. For example, here if I do it 2, it adjusts the margin. So you can play around with the margin here a lot of ways. So I'll keep the original thing intact. Then I need to start plotting, but in the same plot. So I'll use par new equal to 2t. So that means new plot will be created on the same original plot. And then I want to, maybe I want to add density. So I'll add the density of this var variable. Line width I'll specify. We know all these features. Line width 4. Maybe the line should be in black color. So I'll specify the color to be black. I will not, since already there are x and y axis, I will not specify any axis labels. So I'll keep them empty. I'll create my axis as f false. I'll keep y labels as empty. Already I have specified that, and then central heading also as empty. So this is the new plot, and notice how it is plotted. Okay, so I missed the par new t running that. So now if I run it, the superimposing density plot is plotted, which gives some idea of the density. Next, I need to add the axis on the right side. So R recognizes that this axis line is 4th. So this will be the 4th axis for R, the secondary axis. I'll specify the, I'll add the color as black, and let's add the labels as well and as black. So a very nice looking axis is produced. We can see that the axis is produced here. Now if you want to add the axis name, you can add this mtext argument, and here I'll put cell density. I need to specify that it has to be added at side equal to 4. Then maybe color, again I'll stick with the black color. Notice, but it is slightly less suitably placed, so I need to shift on the right little bit. Maybe line argument specified 2 is still not well shifted, so probably that 4. Yes, now it is well shifted. So I'll create the plot again. I'll again run all the commands from beginning, and I'll get the nice looking plot here. So this way I could plot or superimpose 2 plots in the same bar plot and make good use of that. In this video, we'll improve our bar plots and try to produce side by side and stacked bar plots. So we'll try to produce side by side or grouped and stacked bar plots to enrich with more information. So for this, we'll use meal dataset. We'll go to the environment, import dataset, and we have a meal dataset that we are going to use. So in this meal dataset, we'll import it. A brief overview of data is provided. So we'll just copy these commands as we have done earlier. Commands that are appearing on our console window. Now we'll just have a brief look at the meal data. So it seems that the data provides different restaurants, how many restaurants under different pricing and quality rating data that is provided here. So first, let's do a basic group chart or stack chart plotting. Group or stack chart. It's quite easy. So first we need to specify the arguments in the bar plot, which is we need to specify in the matrix form. So this plotting requires matrix form. So metal, and we'll be plotting starting from row number 1 to 3, which will specify that we need to plot the only 3 rows: good, very good, and excellent. These 3 quality ratings. And on the column side, we'll specify column 2 to 6, which is $10 to 19, 20 to 29, so on and so forth up to total values. So that we'll plot. Then we'll specify the color as rainbow 4. Since we have 4 columns, we'll use rainbow 4 for plotting. Border as white. Xlab equal to price, and we can specify Y lab as number of restaurants. Now you can add many more arguments as we have already seen in some of the previous exercises, but for now, in the interest of brevity, we'll stick with these. And when I plot them, notice a very nice looking bar plot which is stacked or grouped. Each bar carries all the three quality ratings: good, very good, excellent. Now in order to enrich this graph, we need to add the legend so that it conveys the full information. We'll add legend probably on the top left, which seems to be slightly empty. So I'll add the legend on top left. I need to specify the labels for the legend, and we'll use the names of those. So we'll use the names: mean, dollar, quality rating. We need to add quality rating as label, and three quality ratings we have, which we'll use as the rating. If I run this command, notice three ratings will be produced, which is good, very good, and excellent. Then 6 equal to 1, which will specify the size of this label. We can change that later. We'll maintain the color coding with rainbow. 3 here also. We'll plot the chart, and then 3, good, very good, excellent. So we have the 3 color codings, and a very nice looking chart is produced. Now often you may want to produce a chart which is side by side and stacked. So for that you need to modify the arguments a little bit. We'll provide them. So I can add beside equal to T. Beside default was false, so we change it to T, and then use the exactly same set of commands to produce the side by side or stacked. You can also produce in a horizontal fashion. So if you want to produce in horizontal fashion, you simply need to write one argument, which is, as we did earlier, horizon equal to T, and you can print in horizontal manner also. So this was bar plotting. In this video, we saw how to plot bar plots in a stacked or group by group manner, or stacked with each other.